Greetings, y'all! In this episode of Purple Bear Biology, we're going to talk about two groups of seedless plants, non-vascular mosses and vascular ferns. We're going to talk about two main topics, their adaptation to land and their life cycle. We're going to use moss as an example. So let's get started. Plants transition to land for three primary reasons. Number one, water filters light, and plants are forced to compete for the top spot. But land offered relatively unfiltered sunlight for photosynthesis and initially less competition for resources. Number two, land offered more concentrated CO2 in the air and nutrients in the soil. Nutrients trapped in the soil give plants more time to absorb them. And number three, less competition and predation, at least in the beginning of the transition, meant that plants could grow without concern of limited resources or being attacked by predators. Despite those adaptations, life on land was not without its challenge. For starters, there was not nearly as much water available. This was a serious problem because mosses and ferns need that water to make ATP through photosynthesis. They also need water to transport their sperm for external fertilization. To adapt to an environment with less water, mosses and ferns developed a waxy cuticle to inhibit drying out. They also developed specific reproductive structures to hold their gametes. These structures are called gametophytes. Gametophytes come in two different types: Antheridia, that house and produce sperm, and Archegonia, that produce the eggs. Also, moss and ferns need to disperse their offspring away from themselves so that they do not compete with their babies for resources. In response to this challenge, they produce spores. These tiny single-celled structures are released into the wind in hope that they will find a moist environment to grow. While those are some pretty cool adaptations, those plants still have some limitations. For example, mosses don't have a vascular system. So this is why they have to live in a moist environment and often don't get that tall. While ferns do have a xylem and a phloem, it's not nearly as advanced as angiosperms or gymnosperms, and this is why they can never get more than a few feet tall. Both moss and ferns rely on swimming sperm, so fertilization occurs mostly after a good rain. And remember that spore, the single cell, to grow an entire moss from? Imagine if your parents sent you out into the world after fertilization. Look out, world! Here comes this zygote! So now that we have an idea of how and why plants had ventured onto land, let's talk about their life cycle. Plants have a really interesting way of completing their life cycle. They have something called an alternation of generation. You see, part of these plants' lives are spent in a multicellular haploid state. I know. Multicellular what now? Remember, your cells have two copies of your chromosomes, one from your mom and one from your dad. We get those copies when the sperm and the egg come together. The zygote that is formed is a diploid cell. Di meaning two copies of the chromosomes that you have. With plants, things are a little different. Sperm and egg still come together. Remember, after a good rain. This produces a structure called a sporophyte. The sporophyte grows through mitosis and grows out of the gametophyte. It bursts out, kind of like the baby aliens from that movie. Oh my God! The sporophyte then undergoes meiosis to produce spores. Remember that meiosis reduces the number of chromosomes in half, creating haploid spores. Those spores are released into the world, and if they find a suitable environment to grow, then they will grow through mitosis into a gametophyte structure. Except, they only have half of the chromosomes, so this gametophyte structure is a multicellular organism with each cell only having half of the number of chromosomes of the original sporophyte. Those gametophyte structures produce gametes through mitosis, and then when it rains, we start this love story all over again. So if we look at this life cycle in moss, we see that we start with spores landing and developing into a gametophyte. This is the green moss that you have seen growing on the ground. After a rain and fertilization, sporophytes grow, produce spores, and the process repeats itself. So when we look at a moss life cycle, we are actually spending most of the time looking at a haploid organism. How do ferns differ? Well, like the rest of the plants we will discuss, ferns flip this dynamic and spend most of their life in the sporophyte state. The process is still the same, it's just that the green structures we typically call fern is a multicellular diploid sporophyte. Pretty cool, right? Okay, so let's summarize what we've talked about. 1. Plants have benefited from the transition to land by having access to more concentrated nutrients. 2. The transition to land, while advantageous, required plants to develop new adaptations to be successful with less water. And 3. Plants have an alternation of generation in their life cycle, where mosses spend most of their life in a haploid gametophyte stage, and all other plants that we talk about will spend most of their life in a sporophyte stage. Well guys, that's it for this episode of Purple Bear Biology. Let me know if you have questions in the comment section below, and don't forget to hit the like and subscribe button so that you can see all of the videos that I continue to release on different biology topics.